Welcome to the chain rule. This is probably going to be one of the most useful sections we have this semester. Chain rule tells us how to take the derivative of a composition of functions, f composed with g of x. And in English it says take the derivative of the outside, that's f prime, leave the inside alone, that's g of x, then multiply by the derivative of the inside, that's g prime of x. And I love this little cartoon over here about differentiating a mother and a baby. So let's look at a super simple example first. What if we want the derivative of sine of 5x? So the outside function is sine. So we take the derivative of sine, that's cosine. We leave the 5x alone, and then we multiply by the derivative of the inside function, which is 5. And typically we want to write our constants out front, so that's 5 cos of 5x. Okay, let's look at the generalized power rule. I think this will make it even more clear. Our old power rule said to take the derivative of x to the n, bring the n down, and then subtract 1 from the exponent. So for example, if we want the derivative of x to the 9th, bring the 9 down, and then we get x to the 8th. But what if we want the derivative of something like this, where it's x squared plus 3 to the 9? That's a function, u of x, to the n. So here's my rule over here. The derivative of a function of x to the n, you do the same thing. You bring the n down, and then you subtract 1 from the exponent. The only thing different is then you need to multiply by the derivative of the inside. That's u prime. And typically I'll give these rules in shortcut version. That's n u to the n minus 1 times u prime. So for example, over here, we bring the 9 down. We leave the inside fixed. That's x squared plus 3. New exponent's 8. And then multiply by 2x. And let's clean that up. That's 18x, x squared plus 3 to the 8th power. Okay, we're going to do a bunch more examples. You might want to pause the video and see if you can do the ones on this page on your own first. Okay, so the derivative of this polynomial. We bring the 50 down. We leave the inside fixed. New exponent is 49. And then we multiply by the derivative of the inside, which is 2x plus 3. Make sure you use parentheses. Without parentheses, that's not correct, because we have to multiply by all of 2x plus 3. And then let's just do a little bit of cleanup. I'm not going to distribute, but I'll put the 2x plus 3 up here, and then x squared plus 3x plus 1 to the 49. Okay, next one, if I want to use the power rule, first I need to write this as a power. So I'm not going to take the derivative yet. This is equal to, I'm going to leave the d by dx here, indicating I haven't taken the derivative, x squared minus 1 to the 1/2. So now I can take the derivative, so drop the d by dx, bring the 1/2 down, leave the inside fixed, new exponent's negative 1/2, and then multiply by the derivative of the inside, which is 2x. And then if I want to clean that up, the 1/2 and the 2 cancel, and I get x on top and the square root of x squared minus 1 on the bottom, if I want to write that with positive exponents. Actually, I use radical notation. Okay, next one. I strongly encourage you to try this one on your own and then come back and see what I do. All right, so this is, the outside is secant. You need to leave the 5x alone. So this is going to be secant, not of x, but of 5x, tangent 5x, then multiply by the derivative of the inside, which is 5. So the argument is 5x, that's got to be there. So let's put the 5 out front. That's 5 secant 5x tangent 5x. And there's our derivative. Okay, on this next page, the problems are in pairs. 2 and 3 are very similar but different, and 4 and 5 look similar but they're very different. So for number 2, this is a composition. Tangent is on the outside, sine of x is on the inside. So y prime is 4, take the derivative of tangent, which is secant squared. The argument we leave alone, that's sine of x. Then we multiply by the derivative of sine x, which is positive cos x. And that's it. There's our derivative. Number 3 looks similar, but it's not. This is a product, not a composition. It's tangent of x times sine of x, not tangent of sine of x. So we need the product rule. F times g prime is f prime g plus f g prime. And so y prime is 4. The 4 is a constant, so that's just going to carry along. The derivative of tangent is secant squared x multiplied by sine x, and then add on 4 tangent x times the derivative of sine x, which is cosine x. All right, and then we can clean that up just a little bit because tangent times cosine is just sine of x. So this is 4 secant squared of x sine of x plus 4 sine of x. Okay, next one, we want the derivative of a power of a trig function. And typically when I'm taking the derivative of powers of trig functions, I'll rewrite them using this notation because then it's really easy to see what's on the inside and what's on the outside. The inside function is sine of x. So y prime is, we bring the 3 down, we leave the inside alone, that's sine of x, new exponent's 2, and then we multiply by the derivative of the inside, which is cos x. And then I can rewrite that using the other notation. This is 3 sine squared x cos x. Okay, so that's y prime of x. Let me erase this here. Y prime of x. You can use y prime as shorthand, but in this case, I want 2 y primes. I want the function y prime of x, and I also want the number y prime of 2 pi over 3. So that's 3 sine of 2 pi over 3 quantity squared. So here's a unit circle. Here's 2 pi over 3. So we want root 3 over 2 quantity squared. And then cosine of 2 pi over 3 is negative 1/2. So that's going to be negative 9 over 8. What you wouldn't want to do is write y prime here and y prime here because they're not both y prime. One is a function, one is a number. Okay, contrast number 4 to number 5. Here we want sine of x cubed. Now without parentheses, what this means is take x cubed and then take sine of that. So y prime is going to be, our outside function is sine. So we want cosine of x cubed. Then we multiply by the derivative of the inside, which is 3x squared. So that's 3x squared cos of x cubed. Very different answer. Okay, last trig example is going to be chain rule twice. The first thing I want to do, since I have the power of a trig function, is I want to rewrite it like this. So I can clearly see what's on the inside and what's on the outside. So y prime is, we bring the 5 down, leave the whole inside alone. Cosine of 2x plus 1, and then new exponent is 4. Then I multiply by the derivative of the inside. The derivative of cosine is negative sine. Since that's negative, you definitely need parentheses. Otherwise, it's subtraction. So sine, and then leave the 2x plus 1 alone. Then there's another inside. We need to multiply by the derivative of inside of this, which is 2. And then if we clean that up, that's negative 10 cos to the 4th of 2x plus 1 sine of 2x plus 1. And there's a derivative. All right, chain rule for e to the u of x. We had a derivative rule that said the derivative of e to the kx is k e to the kx. That was actually a special case of this more general rule that says if you want the derivative of e to any function of x, rewrite e to the u of x and then multiply in front by the derivative of the exponent. So here are 2 examples. The derivative of e to the 7x is 7 e to the 7x. Notice that 7 is the derivative of 7x. All right, here's another example where it's more involved exponent. We leave the e to the 2x squared plus 7x alone. And in front, we multiply by the derivative of the exponent, which is 4x plus 7. Make sure you have those parentheses there. That is not optional. Without parentheses, you'd only be multiplying the exponential expression times the 7. So parentheses not optional. All right, finally, we're going to finish up with chain rule with tables. I know this is a long section, but it's really important. All right, in each case, we want 2 answers, a function and a number. And we'll use the table to get the number. So for this first one, h prime of x, we see h is a composition. It's g of f of x. So we want the derivative of the outside, that's g prime, and we leave the inside alone, f of x. And then we multiply by the derivative of the inside function, which is f prime of x. So that's my first answer. Okay, the second part, h prime of -2 is g prime of f of -2. That's a composition, it's not multiplication. Then I multiply by f prime of -2. Now I'll get all those numbers from my chart. So I want g prime of, I look in the chart for f of -2, and I see that's 1. And then f prime of -2 is -5. Then I go back to my chart and I look g prime of 1, which is 7 times -5, -35. Okay, next one is completely different. So now it's multiplication. It's f times g. So I want the product rule. H prime of x is, I'm just going to state the product rule. F prime of x, g of x, plus f of x, g prime of x. So that's the first part. That's a function. And then I want h prime of 3, which is f prime of 3, g of 3, plus f of 3, g prime of 3. And that's when I go to my table and I get 5 times 0 plus 1 times 5, which is 5. Okay, last two, again, compare and contrast. We're looking at f of x cubed versus f of x quantity cubed. We're going to take the derivative of each one. So big F prime of x, we take the derivative of the outside, which is little f. We leave the inside alone, which is x cubed. Then we multiply by the derivative of the inside. Let me rewrite that, 3x squared f prime of x cubed. So that's the first part. And then big F prime of 2, we can use these values at the top that were given. If I put 2 in for x, 3 times 2 squared is 12. And then I want f prime of 8, which is -1. So I get -12. Last one, big G prime of x. We bring the 3 down. We leave f of x alone. That's the inside function. New exponent's 2. Multiply by the derivative of the inside. So that's my function. And then big G prime of 2 is going to be 3 times f of 2 squared. F of 2 is -2, so that will be 4. And then f prime of 2 is 3, so I get 36. Okay, a lot to digest. And that is the end of this section.